So what's due for Monday is the day 17 handout. So take a look at day 17. So 7-8, 7-9, right? Keep going. 7-15. So that means you cross out 7-13. All right. 7-16. So 7-15, 7-16, 7-18, and then numbers 6, 7, and 8. And those are from the problematic lab problems. Okay? Those are from the problematic lab problems. So it'd be best when you're working those out not to just copy the solutions, right? Try to cover up the solution and work them out. Okay, so you have the solutions. So problems 6, 7, and 8 in the problematic lab problems that we went over. Okay. And I'll be glad to email these 3 questions to you. That might be easier, huh? In case you probably turned them in, didn't you? Oh, we didn't turn anything in. Excellent. So problems 6, 7, and 8. Okay. From the problematic lab problems. Okay, so today, all we're doing is try to get your homework done, right? But I wanted to start out with questions on day 16 homework because I can't disappoint you, even though it's a Friday, right? You got to have a quiz. Otherwise, Gloriana would be so mad. So we got to have a quiz. So the quiz is on one of the homework problems due for today. So I want to start out with any questions on today's homework. And then we'll see if there's any questions. And then after that, we can start working on a bunch of these, right? Or you can take the quiz right away if that's what you want to do, or take it at the end of the hour, or whatever makes you feel most comfortable. So any questions on the homework due for today? Excuse me?
12.
Number 12. I wonder if I even have that. That's not typed up, is it? So I'm going to have to start with a clean sheet. Okay, number 12. Oh, okay. That's on, nobody has a book, do they?
137.
It's on page what?
137.
Page 137. Man, Desiree's got this down. Page 137 if you have your book. Number 12. Okay, the Kaldal one. Okay. Just like with the problematic lab problems, I like to start with what they're interested in. Weight percent of nitrogen. So grams of nitrogen all over the grams of the in protein, so grams of the protein times 100. Now, if you want to do weight percent of N2, fine. It's no different, really. This is okay. This will work. So the grams of the protein, though, take that from the first part. They analyzed 256 microliters of a solution containing 37.9 milligrams of protein per milliliter. So that grams of that protein, right? Because they took 256 microliters, right, of 37.9 milligrams of protein per milliliter, right? Per milliliter. Okay, so do you see how these units are going to cancel? You just have to know what micro is, right? Micro is 10 to the negative 6 liters. So you could just 10 to the negative 6 liters. You might want to go a little bit further. 256 times 10 to the negative 6 liters. Convert that into milliliters. A liter is 1,000 milliliters. All right. Then take that times your 37.9 milligrams per milliliter. So the milliliter, so all we, there, right? So we have our well, it's in milligrams, but convert the milligrams into grams, and we've got the bottom part. Okay? Does that make sense so far? Did I lose you? Andy, did I lose you?
So then you just convert it to milliliters, the microliters.
Yeah, I convert the microliters and milliliters and multiply it by the milligrams of protein per milliliter so I can get the milligrams of protein. Okay? So we have the bottom part of our weight percent. Now we have to get the top part. And now we got to do a little more reading. So ammonia was collected. So they collected ammonia. Well, ammonia has nitrogen in it. So all the nitrogen came from the nitrogen in the protein, right? So that's this whole process, the Kjeldahl process. And they're kind of skipping all that. They're just saying, okay, that's where all your nitrogen goes. It all got converted to ammonia. And they collected it in 5 mils of some acid. So that means they collected in this acid that there's way too much acid, right? They collected it in a place where there's way too much acid. So you're going to have total acid, total. It reminds me of a couple of those problems we did in problematic lab problems. You're going to have the total acid because they collected it. That means they didn't titrate, they just collected it. So that means that 5 mils of 0.0336 molar HCl has to be way too much. And then they go on, they say, and the remaining acid required. Okay, so some of that acid went into reacting with the ammonia, right? But the rest was the excess. It reacted with the sodium hydroxide, right? Does that sound familiar? And then the part that reacted with the sodium hydroxide, they told you. And remember, just get used to it. They told me 6 mils of 0.01 mole. They tell you a volume and a concentration. They told you moles. So just get used to reading that. It makes these questions so much easier. So I know the moles of hydroxide, right? Well, I know the moles of acid that went to react with the hydroxide. It's a 1-to-1 ratio. So whether you calculate the moles of hydroxide or, right, it's 1-to-1. So I can get that moles. I know what this one is, again, because they told me volume and concentration. So I know this moles. Take this one minus that one, I'll get this one in moles, right? Now it'll be moles of H+, but it's 1-to-1. This is the same as the moles of NH3, right? Do you see that? Because NH3 reacts, ammonia is an acid or a base? It's a base, and it reacts with an H+. It's just a funky base, because look what it makes, ammonium. I mean, that doesn't even look like an acid, but it's a weak acid. So it's 1-to-1. So this is really our, all right, here's our moles of ammonia that we're after. Here's our moles of that NaOH that we added to react with our excess. Here's our total H+ moles. All right? We know this one. We know this one. Solve for it. Solve for it. All right? Solve for those moles. And then once you get moles of NH3, how do you get grams of NH3? Let's start with that molar mass. Well, yeah, I guess what I would end up doing is something like, I want to get it into moles of N. It looks weird, but this way I don't screw up. What's the ratio? 1-to-1. So I like putting that in there. Otherwise, I go through all this work, and then I screw up on the silliest step. So it's 1-to-1, and then molar mass of N. Someone said molar mass. And N is what, 14 grams? Okay. And I can write the numbers in, so in case you don't have your book, right? Like the, let's see, 5 mils, the total acid, that one was 5 mils, and it was of 0.0336 molar HCl. And then the NaOH, that was 6.34 mils of 0.01 molar NaOH. Okay, so convert this to moles of, all right, convert this to moles of H plus, convert this to moles of H plus, subtract the two, and you'll have the moles of H plus that reacted with ammonia, which is the same as the moles of the ammonia, because it's 1 to 1. Then convert the moles of ammonia all the way to grams of nitrogen. Then you're ready to finish off your weight percent. Go way up here to the top. You have your grams of nitrogen. Okay. Did anybody get an answer for weight percent? Anybody get a final answer for this thing?
15.1.
15.1. Now I got 15.1 too. So see if you can get 15.1%. And if you got it, instead of twiddling your thumbs, go ahead and start on the homework, right? What's the very first one? It's 7-8, right? You gotta do it anyway. Might as well get it done while you have people around to help you. And then when there's like 10, 15 minutes left, we'll stop and we'll take the quiz for today. Oh, that's their final answer. So you got to get the grams of nitrogen here, put it all the way up into the weight percent. Grams of N. That goes up on the top. Right, so that does that. Whatever you get goes up on top. And then times 100. And you have to divide it by your grams of solution.
Which would be that. And I got 30.
This is milligrams, though. That has to be 37.9 times 10 to the negative 3 grams.
Well, that's what this is.
You took this times 37.9?
Mm-hmm.
That's milligrams. You want grams. You want grams to be canceling. Milligrams is going to cancel with grams.
Okay, I see what I did.
So when you're getting that, realize there is an additional step here. Let's clean this up. To get those grams of protein, you got to keep going because you're in milligrams. Otherwise, your units aren't going to work out, right? So you got to keep going. About 9.7024 times 10 to the negative 3. Hey, Ricky, what did you get for your grams of nitrogen?
Oh, for grams of nitrogen?
Yeah, so then people can check.
0.001465.
So 3 zeros, 1465.
Oh, it's 2 zeros, then a
Oh,
1,
2 zeros. I can get rid of
then
that.
a 4, then
Okay. 0.2 zeros. 1465. Okay.
Was that for grams of nitrogen or grams of protein?
Grant, the bottom.
Oh,
See what I have the bottom number up here is my protein. Here's my nitrogen.
so it's
So this isn't right. Grams of nitrogen should be 1.46 times 10 to the negative 3.
because it's milligrams of protein, of nitrogen, right?
I'm not sure. What I'm looking at is up here for that protein. Here, this is the part where you need an extra 1,000.
Okay.
So there is no milligrams down here, but there is right here.
Okay.
Maybe that's where you got screwed up. But the grams of nitrogen should be 1.46 times 10 to the negative 3. So if you can get it, go on and start doing the homework. If not, let me help you or ask somebody.
But this one, I know how it's supposed to be multi-jitter, but on the bottom, like, is it supposed to be 1,000? Or do I just jump?
So you started, how many milliliters of 0.167 molar K04? So, well, you're starting weird. You're starting weird. So there's two places to start. Either start with this guy flipped,
That's what I'm about to
or
say,
start
this
with
one.
this, and then you'll convert all the way to milliliters.
Can I start with the big molar?
You can. Well, you want mils of
Okay.
this, so I would start with this guy flipped, because that would be liters flipped, liters on top.
I'm gonna do 6, 7, 8.
Okay. Okay. So I just cross that. I want to cross out 17 and 13, right?
Yeah.
Oh, okay. Well, why the heck did you do these already?
So if you're doing 8, there's 2 ways to start, I think. Did it work?
Yeah.
What'd you get as the final answer? Well, let me know what you got as the final answer is. Get to work.
I'm about to start this one. Can we just take the quiz already? Waiting is making me anxious.
I know, isn't that cool? Isn't that thing really cool? It was the most frustrating thing to build, though.
Sterling what? What is it called? The Sterling machine?
Stirling engine.
Engine.
Same thing, Stirling machine. I don't know. Did you get an answer? Oh man, yeah, 43.2. Let me write the answer down. 43.2 mils is the answer for 8. So in number 8 here, you could start with this guy flipped, right? Because then you'd have liters up on top. But conceptually, it kind of makes sense too, just to start with this, because the whole idea of titration is moles equals moles at a titration. So very often folks just start with 108 mils and just convert all the way to mils of KMnO4. But either place would work to start. They're both equally valid starting points. Now, did you get answers for the other ones? What'd you
Ricky
get?
got the same one.
For 270 for B. B, folks are getting 270 mils. 2 people did. If you'd like me to see me work these out, I'll be glad to work them out. Uh-huh.
For the grams of protein, I keep getting -5 because it's supposed to be -3.
It's 256.
Oh, did you put to it? Oh.
It's 256.
Are we doing a bottom line ratio right here?
So you've got, where are you starting here? Oh, we started with 108 mils, okay? Then you got into liters, and then it's liters, you're talking about this oxalic acid stuff. So I would write MOL of pretty much of this thing, oxalic acid,
Oh, that's what it is. Okay.
right?
So it's 5 moles.
And then it'd be 5 moles for every 2 moles of permanganate. Yep.
2 moles?
Yeah, because 5 to 2.
Oh, okay.
Why would you convert it to liters?
Oh, because in order to get there, we need to use, we're talking about permanganate, and we're starting with 108 mils of the wrong solution, oxalic acid. So to get there, you got to use mole bridge. And to use mole bridge, you got to get into moles. Well, to get into moles, you got to get into liters first. It's a very long stepwise procedure there.
It sure looks like it. I think you have to make people watch it. It's hydrated.
Instead of this one.
I get that. I changed my major. I'm just kidding, Rowan.
Did you hear him?
That'll be the day she shows up for volleyball.
Oh my god. Ricky was like, that's it, I want to go change my major.
Like I said, the day you show up for volleyball.
Just imagine starting all over. You know how, God, it would take forever.
Please get your general out of the way.
There's always a positive aspect. Look at her.
It's that cheesecake. A lot of kilograms.
That's my setup. I don't have the numbers in there, but that's the setup.
So question, for this for the malt bridge, would it be the
See that? This H2 is supposed to be written over here. It's kind of a mistake. Because the acid, all acids, acidic hydrogen is always out front.
yeah.
So, but there's 5 moles of this acid for every 2 moles of KMnO4.
Yeah, so it would be the 2 over there.
Yeah, and that because it moles of the acid has to be on the bottom, otherwise it won't cancel.
It's hard to work in open space.
Man, how can you even read that back here? You can read that? Why don't you sit up there at least? Yeah, there it is. Anybody get an answer for 9 yet? .149 is the molarity.
I got the same thing as first.
Did you guys do it independently though?
Yes.
Really? Okay. It should be right then.
But she didn't share her cheesecake.
So hopefully you're getting these. 43.2 for 8, 270 for part B. Did you notice the do-over on chemistry with Dr. Smith? There was a do-over. Everything was, all that bad experience in class was just gone. It never happened. Oh no, I deleted that part. I deleted the bad part. It's gone. Poof. Remember where I screwed up in class last time? Something with, it's going to be very similar. It's going to be very similar to number 15, where I screwed up in class last time. Yeah. So 15, see if you can get to 15 before you leave today, because 15 is very similar to the screw up in class that I had last time. But there's the solution posted like it never happened. So which one are you on? Oh, okay, okay. Okay, so here there's 2 places to start. They want milliliters of this. So you could start with this thing flipped because you have liters up on top. That's one place to start. Another place to start is these are titrations. So this milliliters of this stuff is chemically equivalent to milliliters of this stuff. So you could just start right here and go and convert all the way to mils too. Either way works. So there, my game plan for number 9 is up here. If you haven't figured out number 9, right? They ask for molarity. So again, I always jump to what they want. They want molarity. So then I just start working with it. They told us the bottom part, liters. They said it was 1 mil. So I know that I have 1 mil of the solution. And then the top part to get the moles, well, I'm going to convert the 1.69 milligrams of ammonia, use the mole bridge to get it into moles of hypobromite, and then substitute it into my molarity expression. It should work. And a couple folks got 0.149 molar. It's the final answer.
Is that for the
That's the molar mass of this whole thing.
of the whole thing?
Yep. So this problem is very similar to that one that we did in class where you had to say, let X be the number of grams of one of these, and then that number minus X is the number of grams of this one. Yeah, that's one to make sure people get caught up here. We'll get you started on 15. You can do it though. You have all the tools. Now here, what's going on here? Oh, I see. You're converting it to grams. And then you got mole. Okay, that makes sense. Good job. Good job. Okay, we have a few minutes left here. So, okay, this is very similar to one that we did in class that I reposted the correct video on it. And what they're saying is that you have this mass and all it contains is these two compounds, this and this. You add them up and you have 0.05485 grams of solid. Okay, so what we're going to do is we'll let this one be X and we'll let this mass be 0.05485 grams minus X. Okay. So that's all. That's the trick to solving this. That we're going to say we have a total mass of 0.05485 grams mixture of two solids. Well, one is we're going to call, let's have it be X grams, and the other compound, the iron chloride, will be 0.05485 grams minus X. Okay. No, we're just saying, so X, right? So that's how we're defining them. That's their masses. And we can get it into moles, right? So the moles of each, right? That would be what? You'd have, if you know grams, would you be taking it Dividing it by the molar mass or multiplying it by the molar mass? Divide. So you'd have to have 329.13 down here, grams in a mole. This one, you'd have 0.05485 grams minus X. His molar mass is 234.84, so divide by 234.84, right, in a mole. Okay, so now we have the moles of each. So this is the moles of, we have the moles of each one. Well, they tighten, and that's what we need. We need the moles of each one. If we added them up, we'd have the total moles of each one, right? If we added them up. And we know both these compounds are reacting with cesium, right? Because cesium reacts with both of them. They're both iron plus 2. It looks weird, but this is iron plus 2. This compound is iron plus 2. Cesium plus 4 reacts with iron plus 2 and converts it to iron plus 3. So the cesium plus 4 reacted with everything. And they told us, again, they told us a volume and a concentration. They told us moles of cesium. Well, we know the total moles of everything then. So we know we can set a number that total moles of cesium equals this plus that. One equation, 1x. Right? And yeah, it looks ugly, but we have calculators.
So you said it equals to 0.0123?
Whatever this number times this number is.
Oh.
Right? Because it has to be moles. Has to be moles.
Oh, got you.
It's going to equal 0.01339 liters times 0.01234 molar. Okay. So we have one equation, one unknown. Okay. So the algebra isn't. I would just simplify things with the calculator. Makes it a lot easier than doing a lot of algebra. Okay. And solve for your x. All right, solve for your x. And I think this is where we screwed up in class. Remember, your X is grams of that iron sulfate, ammonium sulfate compound, right? It's not grams of iron or anything like that. And they want the weight percent of chloride. So you're pretty much going to have to start with getting the moles of the, get your X, find out what the grams of iron 2 chloride are, convert the grams of iron 2 chloride all the way to grams of Cl. And then you calculate your weight percent. Let's get to it times 100. Right? So that's the idea. Solve for your x. Use your x to get the grams of iron 2 chloride, hexahydrate. Convert that all the way to grams of chloride. Okay, so there'll be some funky mole ratios there, like 2 moles of chlorine, 2 moles of Cl for every 1 mole of this iron 2 chloride hexahydrate. You'll need the molar mass of chlorine. So you've got the game map. That's good enough to get started. So let's take the quiz and